Am I audible now? So, okay, let's begin with the session. So before we begin, let me first ask you all guys, is this your first Vedantu masterclass? You all can mark your options with A or B, A for yes and B for no. So, all right, maximum number of students are appearing here for their first masterclass. All right. So before we begin, I'll be talking about the ways and certain strategies needed for you to crack JEE 2020. So in this lecture, we will be going through the AC circuits. We will keep the topic short, and the basic motto would be to make you all aware of the technology and the platform that we use. So guys, I am Pritesh Ranjan, physics expert, and I have taught and mentored more than 10,000 students over the past 6 years. Over 500 plus students have scored more than 85% in their boards. So, okay. So this is a sample question which we will be working out at the end of lecture. It is based on alternating current. So I hope you all guys are from class 12. So anyone who is from class 11th, do not worry at all. This topic is from class 12 CBSE syllabus. Okay. So let me just give you a quick introduction of the platform. So through this chat platform, you guys will be able to chat with the teacher and students as well. As I can see through the chat box, many of you are already chatting. So you would be basically interacting with other students and teacher as well. Also, your doubts will be instantly cleared with your academic mentor via question and answer panel. So you will be able to give poll answers with hotspots. You will be able to mark your answers accordingly. There will be a hotspot released by which you will be receiving the options. It will be the sample form of quiz that will be based on the topic being subsequently covered up in the lecture. So the quiz will be live and fastest finger list to test your real-time performance. So leaderboard, it will be used to know your overall class rank and earned points. So you have a JEE crash course. Through this, you will be provided with 12 online interactive sessions per week. Special 20-week long fast-track program are also implemented. So complete revision of pre-midterm syllabus will be provided. Full post-term syllabus coverage will be done. On-demand concept videos will be made and unlimited doubt solving will be provided. Yes, guys. You will be provided with unlimited doubt solvings. You may ask any doubts through chat box or through academic mentor, and we are always happy to help you. So the batch is going to start with from 14th October. It has already started, and Monday to Saturday from 7 to 10:30 p.m. So this is the sample JEE crash course. Its start date 14th October 2019. Every day from Monday to Saturday from 7 to 10:30 p.m. So yes, guys, the course is generally being offered at 29,997 rupees, and this is a lightning deal by which you can use my coupon code PRIT01 to join this lightning deal. Approximately 50% waive in the fee. So I'll tell you guys how to avail this lightning deal. So here, as you can see, when you go through this page, you have to click down this link over here, and you have to click on the enroll now, which you can see here, something like this. It will appear on the page, and you have to click on I have a coupon code. So guys, if you don't click on I have a coupon code, you will not be given any discount. So make sure you apply the coupon code PRIT01 so that you can avail your discounts. So, okay guys, that was all about this platform. Let us now move on to the sample topic, alternating current. So many of you would have already have an idea about alternating current. So let me first ask you, before moving into this lecture, the current that is supplied to our houses, that is an AC current, option A, or is it an DC current? So you have two options, A or B. So yes, approximately all of them are correct. So yes, guys, whatever current that we get in our households, that is alternating current. So the basic definition of alternating current, it's a type of current that continuously changes its magnitude as well as direction. So there is a periodic reversal in the direction. So alternating current, as you can see, it is represented by this equation I is equal to I naught sine omega t. So where omega is the angular frequency, which is 2 pi by t, which is also equivalent to 2 pi f. So here I naught is the peak value of alternating current. So basic thing that I wanted to convey from here is that whatever current that you get in your household, that is continuously changing its magnitude as well as direction periodically. So current, it is represented as I equals to I naught sine omega t, angular frequency 2 pi n. You can take this n to be f. It represents the frequency. So here you can see the visualization of how this alternating current varies with time. With respect to time, the current value changes, and at certain times the current reaches its maximum value. So this is the form of current which we are receiving in our household circuitings. So okay, whatever current that we are receiving, we need to calculate different values from that. So basically we are interested in calculating the mean value of current, the average value, which is the same as the mean value, and the RMS value. So mean or RMS. So the guys who are in class 12, they might already have this idea about mean value of alternating current, average value, and the RMS value. So what is mean value of AC? I'll give you a quick formulation in mathematics so that you can find the mean value of alternating current. So mean value of any function, it is written as integration of fx dx divided by delta x, where the function is ranging from x1 to x2. By this definition, you can find the mean value of any function. This is a mathematical way to find the mean value. But here we are interested in calculating the mean value or the average value of current that we are receiving in certain time frame. So for that, I'll be using integration ft dt divided by delta t from time t1 to t2. So basically what I need to substitute here in place of ft is I, which is equal to I naught sine omega t. So you can observe here guys, this I is now a function of time t. Based on the time, this value of current or the instantaneous value of current will change. So you can apply this value of I naught sine omega t, and you can keep it in place of ft, and you can find the mean value or the average value within any time frame from t1 to t2. I'll also give you a quick way by which you can find out the RMS value instead of mugging up the formulas. So RMS value, as the name suggests, it is root mean square. So first what you do, you start from the back end. You square the value of f, so it becomes f square x. Take the mean of that. So mean, how you take? Integration f square x dx from x1 to x2 divided by delta x, and you take the overall root. So guys, I'm again repeating, root mean square. You can start its reading from the first root mean square. R for root, M for mean, S for square. But in order to perform mathematical operations, you have to reverse, you have to go from the previous side or the back side. So first you have to square it, you have to do S, and then you have to do the mean, and then you have to take the root of that. So by this you can find the root mean square speed, and by this formula you can find out the mean value of any function. So basically here we were talking about current. So here you can see the mean value of alternating current is 2 pi times its peak value. So here they have given the mean value, and I'm suggesting you to just go through this, use this formula and find the mean value over half cycle and full cycle. Half cycle and full cycle. So guys, I will tell you, within half cycle, your change in time will be from 0 to t by 2. And over full cycle, the time will be from 0 to t. T is basically one cycle. T represents the time taken to complete a cycle. So alright guys, this was the demonstration about mean value or the average value, and in fact the RMS value. So let me just introduce the different components used in AC circuiting. You would have observed, you would have gone through this DC circuits in class 10th or 9th, where you used only resistor as the component. But here in AC circuit, we will be using resistor. We will be using two other components that are new to us, which will be introduced in class 12th. So the guys in class 12th would already be aware of this. The other two components are inductor and capacitor. So very quick review about capacitor. It is an electronic device that is used to store charge, or basically it is used to store energy. What is an inductor? It is also an electronic appliance that is used to store energy in the form of magnetic field. So you would get the idea of this inductor when you cover magnetic field in class 12. So this is just a simple demonstration for the guys who are in 12. You could see here. So you could see here the circuit that is represented by the AC source. So guys, you would have representing the DC source using a battery, something the symbol like this, but you will represent the AC source as the symbol which I am showing here. This is the representation for AC source. Okay guys, so here you can see this AC source is providing the supply of current, which is IC. Why I have represented written here IC? Because this current is being passed through this capacitor. So some voltage is across this capacitor. So you would have known that Q is equal to CV, the only formula used to describe the capacitor. For resistor, you guys already might have known through the Ohm's law, V is equal to IR. V is the potential drop across the resistance. I is the current flowing across the circuit containing the resistor R. So in the same manner, we have the study for capacitance, where we have the equation Q is equal to CV, and every current source in AC circuit, as we have learned, it is I naught sine omega t. This I have already introduced in the previous slides. So from this value of I can find the value of voltage being supplied through the AC source. So I will use Ohm's law, where we have V equals to IR. So this I can use only in case where I have the resistance. But here we are talking about capacitor. So Q is equal to C V naught sine omega t. So basically this C V naught is your maximum value of charge. And I equals to I naught sine omega t plus pi by 2. You would have gone through this using the phasors. We implement all these formulas in a very quick manner. So I'll be introducing phasors as well in the upcoming sessions. So do not worry about these equations. We have a very quick approach to get these equations as a conclusion from the phasor diagram. So okay guys, Similarly, as we had the capacitor in the circuit which was connected to the AC source, in the same manner we have an electrical component, that is inductor. Inductor, you can observe that it is represented in the coiled manner. It's also something like choke coil. So here magnetic energy is stored in inductor, and these are the equations that you have in inductor. VL is the voltage across inductor, that is L di by dt. You could have known this value using the voltage equals to minus d phi by dt, where phi is the value of magnetic flux. So the rate of change of magnetic flux will induce an EMF inside this inductor. So all these things will be clear. Do not worry about this. We will be covering it in when we will be exploring the phasors. So phasors, yes, phasors guys are very important to undergo all these equations in AC circuiting. So at the end, if I have time, I will surely go through the quick introduction about phasors so that I can let you know how to derive these equations. Earlier, guys, we were reading about and we saw the circuit that was containing either of the components. Either it was containing resistance, either inductance, either capacitor. But here we will be focusing on the circuit where two or more than two electrical components will be present in series. So this is series RL circuit. So you can observe that the resistance is being connected to the value of this inductor. And as you can observe that AC source is emitting, it is having voltage V, and this is the instantaneous voltage. V equals to V naught sine omega t. I equals to I naught sine omega t. So the full chapter, full content, it rotates about these values of I and V, which are instantaneous. So before I cover up the session, I'll be first introducing phasors. Again, I'm telling you because these equations will become very much clear when we know all about phasors. So okay guys, you can see, observe here the growth and decay of current that you observe through or in the RL circuit. So here in the similar manner, I have connected LC circuit, the circuit containing inductor and the capacitor. So here is inductor, here is capacitor, but there is no AC source. So here what we can observe, that the resonance condition is being followed up here. So what is the resonance condition? I'll just give you a quick recapitulation. Resonance is a condition where the frequency is maxima. So that frequency we call it as resonant frequency. So guys, what is the resonant frequency? Whenever the value of resistance through L, which we call it as inductive reactance. So I'll be introducing this in the upcoming slides. So basically any electrical component that we use in our circuits that offers some resistance, right? It is not only the resistor which is offering resistance. Any circuiting component that I'll be connecting through the circuit that will offer some resistance. So the resistance being offered by inductor is what we call it as inductive reactance. So let me write down that the term inductive reactance. Similarly, the resistance offered by capacitor is what we call it as inductive capacitance. Inductive capacitance. So guys, now it would have been very much clear to you that if I use all the three circuiting components LCR in a series form, here as you can see, I have connected all these three components: R resistor, L inductor, C capacitor. I have connected them in series through an AC source. So you would observe here that the total resistance being offered by all these three components individually, the resistance, the inductive reactance, and the capacitive reactance. So we do not take these individually. We just need the total resistance being offered by all these three components, and that is what we call it as impedance of the circuit. Impedance of the circuit. So guys, what is impedance? We call it as the total resistance being offered by all the three components LCR when they are connected in series to the AC source. So guys, we represent impedance by Z, and again I am telling you, I am repeatedly being telling you all these equations. Although I have written over here, it's not possible to cover everything in a single session. This is a basic demonstration, but all these equations, all these formulae would be very much clear when you go through phasors. Phasors are very much important in order to explore alternating current. All right, so just a quick view that impedance is written as root over R square plus XL minus XC square. So what is impedance? In basic terms, R square plus XL minus XC whole square. So XC is what, guys? The inductive reactance, that is L omega. What is XC, guys? It is the capacitive reactance, that is 1 by omega C. So I have put these values of XL and XC here in the equation, and I have got the value of impedance. So before we begin with these questions, let me quickly give you a quick approach on the value on the phasors. So in the phases, guys, I'll be taking the resistance across this direction, inductance across this, and capacitance across this. I have fixed these values, and I'll be taking the current along resistance and the voltage across y-axis. So from here, guys, you could observe that the motto of making this arrow is to know the directions and the values for instantaneous current and instantaneous voltage. So you could use this formula now to go to the following quiz. We have the value of Z as root under R square plus L omega minus 1 by omega C whole square. So this is the value of impedance, and the value of lagging potential difference, or the value of lagging phase, it is tan inverse XL minus XC by R. So guys, let me give you a full overview of phasors. So in the phasors, what do we keep in mind? The resistance across x-axis and inductance across y-axis, capacitance across y-axis as well. So up direction I have fixed for inductance, down direction for capacitance, and the extreme right direction for the resistance. So this side is taken for current and the y-axis is taken for voltage. So if I say, guys, this is just a demonstration, if a circuit is containing only resistance, what will be the value of current and voltage connected to the AC circuit? So for that, AC circuit will supply voltage, and voltage will be known, that is V naught sine omega t. So this must be known. Depending upon this voltage, I will determine the lag or the lead in current. So you can observe here, resistance is only across the right. So voltage and current will be to the right, and I can write the value of I as I naught sine omega t. And how could I get this value of I? By just using Ohm's law, V equals to IR, and the value of I will be V by R. So I can divide this whole thing by R, and V by R, I can write it as instantaneous current. That is I naught sine omega t. So guys, you can see I have got the value of current using the value of voltage through phasors. So let me now use phasors to determine the value of L, to determine the value of current when the value of voltage will be given by AC source. So main thing concerned is to get the value of current or voltage through the L or C circuiting components. So as you can observe here, I is across or towards the right. So I'll take the value of voltage as V naught sine omega t. Let us fix this value. Let us fix this value of voltage for an AC circuit. Now let us try to get the value of current involved in the L circuit, or the circuit containing only inductor. So you can see here, guys, inductor is to the right and current is to the, inductor is in the upward direction and current is to the right. So you can observe that current is lagging behind the voltage by an angle of pi by 2. So this is the lag, guys. So current is lagging behind this voltage. Voltage is across Y by an angle of pi by 2. So using this value of V, which is equal to V naught sine omega t, you could get the value of I. So I will be I naught sine, and in the bracket I will write omega t minus pi by 2. So guys, why I am introducing this term minus pi by 2? To show that the current is lagging behind this voltage by an angle of pi by 2. So similar will be the case in case of capacitor. So for capacitor also, let us fix this value of V equals to V naught sine omega t. And as you can observe that V is across this, and current now leads this voltage by an angle of pi by 2. So in case of capacitance or the circuit connected to AC source in capacitor, I will have the value of current as sine omega t plus pi by 2. Only this change I need to make with the help of phasors. So I covered this phasors little bit fast. Do not worry about it. We will be going into details of phasors once we start with our regular session. So just based on these formulas, formula of impedance, formula of current, formula of leading and lagging, let us just go through the quick quizzes where you can mark your options down. So yes guys, I have these questions and I'll be starting the timer. You have 4 options. You can mark your answers accordingly. So the time starts now. So alright guys, well done Sanju Dhaliwal, Nikhila Sajidran and Shivam Singh. You, I expected correct answers from all, but well done, you at least tried it. And let us see the result. Many of them marked A, B, C, D, but the correct answer is D, both A and C. So let us just go through this question and let us try to understand how did we get both A and C. So you can observe here an alternating voltage V equals to 200 sine 300t. So if you remember guys, I have told you the value of voltage from an AC source as V naught sine omega t. So from here, what is the value of V naught? 200. And this is applied across a series combination of R, L circuit. So here L is in millihenry. So what is the SI unit of L? The inductor, it is Henry. So you need to convert it to SI unit, that is 800 into 10 to power minus 3 Henry. So we have the value of L, we have the value of R. So the total impedance, if I recall the formula, it was root over R square plus XL minus XC whole square. So here no capacitance is present. So I'll take this value of XC to be 0 and I just write the impedance to be root over R square plus XL square. And if you would have remembered, I have given you the value of XL as L omega. So you have the value of omega here, which is 300. So you can just look upon here the standard equation and compare it. So you have omega is 300, L you have it as 800 into 10 to the power minus 3. So when you multiply it, you will get XL as L omega, which is 800 into 10 to the power minus 3 into the value of omega, which is 300. So you will get 240 ohm. Similarly, you have the value of R as 10 ohm. So when you take the root of 10 square, that is 100, and 240 square, you get the value of 240.2 ohm. And C part, the peak current in the circuit is this much. So how to get the peak current? So if you guys observe here, this 200 is the value of peak voltage. That is V naught is given as 200. So I will use Ohm's law that states that V is equal to IR. But here I will not be talking about R because two components are being used over here. So I'll be talking about impedance. So V equals to IZ. So I can get the value of peak current. So instantaneous current will be V by Z. So peak current will be V naught by Z. Z, you already have it, 240.2. So when you divide this 200, which is the value of V naught, by 240.2, you can get 0.8326 ampere. And this power factor, guys, this option is not correct, but let me just introduce you what you mean by power factor. It is the value of cos phi. Cos phi is what we call it as power factor. So what is this phi? Phi is the phase angle or the phase difference by which the voltage or current is lagging or leading. So this is an LR circuit. Let me just take you back to the phasor. In the phasor, if you would have remembered, this L is in upper direction and R is in right direction. So you could observe that the value of phi here will be tan inverse, or you could write tan phi is equal to XL by R. So actually the value was XL minus XC by R. But since capacitance is not present, so XC will be 0. So alright guys, let's move on to the next question. So yes guys, you can. So yes Suprati, I will explain it again. With the help of this question, you will be demonstrated the every concept that will be used here regarding phasors or anything. So let's just try and solve this question. So I'm starting the timer and you all can mark your options accordingly. So yes, time's up guys. Let me just check the results. So B is the correct options. Many of them marked B. So let us just use the concepts that we learned earlier and let us try to get the answer here. So a AC circuit consists of capacitor of XC30 ohm. That means they have given us the value of capacitive reactance. A non-inductive resistor of 44 ohm. So this is a non-inductive resistor, 44 ohm, R1, 44 ohm. And a coil of inductive resistance, that means they have given us the value of XL, which is 90 ohm. And a resistance in series is connected to 200 volt and 60 hertz AC circuit. Find the impedance. So for finding impedance, guys, we don't require these things. We just require the formula. So yes, Sophia, I checked your answers. You were correct. So okay, Z was equal to R square plus XL minus XC whole square. So this was the formula for impedance. So here it's mentioned that a circuit is connected to a capacitor. So let us try to frame the circuit. So this is an AC source. Circuit is connected to a capacitor, an inductive resistance and a coil of inductive reactance 90 ohm and a resistance in series. So basically two resistances are there. One is capacitance and it is connected to a resistor, it is connected to an inductor, and again it is connected to a resistor. So basically we need to find out the value of impedance. So R you all can get by the use of R1 plus R2, because two resistances were present over here. You can put the value of XC over here, you can put the value of XL over here. XL, inductive resistance of 90 ohm, XL is 90 ohm, this is XL. So you'll get the value accordingly as 100 ohm. So just you have to use the formula for impedance, that is R square plus XL minus XC whole square. So you can look upon the working here guys. XC, R1, R2 and XL were given. You were instructed to find out the impedance. You use the formula root over R square plus XL minus XC whole square. So instead of R, we were having two resistances. That's why we did R1 plus R2 and R square. So basically this R was for R in series. So you get 100 ohm from here. So okay guys, let us try to find out the current in the same circuit, whereby we use the same components with little change in the resistance values. So I am starting the quiz. So the timer goes now. So congratulations Sumant, Abhishek, Sanju and Aswin, you answered it correctly. So B is the correct option. Let's try to use our theories that we learned today to get the answer B. And yes, Sumant, your answer, non-inductive resistance. You wanted to know the meaning of non-inductive resistance. So it's a kind of resistance that offers no inductance. It's a kind of resistance that offers no inductance, or basically no inductive reactance. All right. That means it doesn't oppose any change in the current flowing through it. So okay, let us try to use the concepts and get the answer over here. You can look the working. Current in the circuit, how will the current be given? As we know, according to Ohm's law, V is equal to IR. But here instead of R, again I am telling I'll be using Z, because the total resistance I have to consider here, since many components are being connected over here. So I'll get the value of I from here, that is V by Z. So we are already being given the value of V, that is the source of AC voltage supplied. So 200 volt divided by the impedance value we have already computed in the previous sum, that was 100 ohm. So when you divide it, you get 2 ampere guys. Okay, let's move on to the next question. So guys, you try to answer this question. Again, I'm just giving you the formulas that you may use it, because this is the very first lecture. So R square plus XL minus XC whole square is the value of impedance. Voltage is equal to I into Z. So you could use any of these formulas, whatever required, and you may proceed with the question, and your time starts now. So congratulations Abhishek, Ravi, Lighty aspirant, Ahmed Aliskar Ali. Your answers were accurate, they were correct, and the correct option is C. Let us try to get how we get the value of C. So here a circuit consisting of capacitive reactance, that is Xc is given. A non-inductive resistor, that means R is given. This is non-inductive. Again, listen here, concentrate here guys. It is non-inductive resistor. That means R1 is here, and a non-inductive capacitive reactance, that is resistance, that is 90 ohm. This is XL value given, inductive resistance, and resistance of 36 ohm, that is R is given. It is connected. So you could find the value of Z from over here. You can watch over here. So what value of Z we will get? We will get the value of Z as root under R square plus XL square. There is no capacitance being observed here. So at C value, it will be 0 guys. So we will get the value of Z as root over R square plus XL square. So when you put the value of XL and R, you could get 97 ohm as the impedance of the circuit. So C is the correct options. So that was all about today's lecture, guys. It was on alternating current. That was just a basic demonstration. So guys, if you didn't understand it, do not worry at all, because this alternating current, it's a part of, first of all, class 12 syllabus. So many of the students from class 11 would might face some difficulty. I agree with that. And students in class 12 who would not have gone through this chapter, it's a complete new unit for you all. So we will be covering it one by one in a stepwise manner, whereby first of all my motto will be to start with phasors so that you can understand from where these equations actually jumped up, from where they came, from where did I get I equals to I naught sine omega t, from where I got v equals to v naught sine omega t. So all these things we are going to explore in our upcoming sessions. So keep connected, and let us just quickly recapitulate the crash course that we will be offering. It's a 12 live online interactive sessions per week and special 20-week long fast track course, whereby complete revision of pre-midterm syllabus will also be provided, and full post-midterm syllabus coverage, and on-demand concept videos. Whatever doubts you have, you can send us. We will make a video. We will make 100% sure that it is clear to you. Your doubts are being solved. So the start date again, guys, you can observe here from the 14th of October, Monday to Saturday, regularly time interval from 7 to 10:30 p.m. IST. So you can avail this course through the site by clicking on this link. So you can buy it now. You have to use the coupon code that will save 50%, that will give you a discount of 50% from 29,997, guys. You are just getting it for 14,999. All you have to use the coupon code, just keep in mind PRIT01. So this is the page that you will be following through. So you have to click on this link, and you have to click on enroll now options. Something, the page like this will appear. You have to click on enroll now, and there you have to click on I have coupon code. So guys, do not forget to check on this box, because if you won't check to it, you will not be availed any discount. You will have to pay the full course. So if you apply the coupon code, guys, you can get it for 14,999. So this was our previous problem that I have introduced at the start of the lecture. So let's just have a quick answer for this. I'm starting the quiz, so you all can answer accordingly. For which angular frequency omega will the circuit behave like a pure inductance? So I appreciate, guys, you might face difficulty answering these questions because I had to start with basics. Do not worry at all. You will be treated starting from the very basic, from the scratch. I'll be covering the alternating current and everything in physics, whatever course or whatever topics are there. So time's up, guys. Let's just now watch the results. So congratulations, Sanju Dhaliwal and Uma Tyagi. You answered it accurately. And the correct option is C. That is 2 by root over LC. So that was all about today's lecture, guys. And hope you really enjoyed the session. So do join the course, and let's meet up in the subsequent lectures. So yes, Tejas, that's it for the webinar. This was just a quick introduction through the mechanism, how we teach, how we interact through students, how we solve your doubts. So thanks, Suman. Thank you, Sanju. Thank you, Suman. Last one, actually, Suman, the timer has gone now, and timer has gone, Suman, and I will surely explain the last one in the upcoming session. So, okay, bye everyone. Take care. Hope you had a very good session. Bye, Supriti. Bye.